All right, my collection of supplies here, and I have a little device that I'm going to show you. It looks like it has something that spins on its axis there, and when I take it out, I can see that there is copper wire. I can see that there is metal plates here that are kind of ridged. And there, inside this device, there are two magnets. Looks like there's a north magnet and a south magnet. So we can fit this right back in here, and it looks like it spins. Here's another one. And it has the same setup. It has tightly wound copper wire. So I can see this is copper wire that's all wound around. It's very thin, and it fits directly into this magnetic field here. And this also spins. All right, so I got a lot of questions about scenario B or C for question 1 of the lab. But essentially, it's asking what's the difference between a motor and a generator? And can this device be both? Okay, so if I have just the device and I put in some kinetic energy, that's my physical movement of the shaft, and that spins the copper wire, which excites the electrons inside the magnetic field, that generates electricity. Okay, if I add electricity, which is the battery, and the electricity from the battery is what is spinning. Okay, so it can either spin the shaft itself and create the movement of the wire within the magnetic field, or the casing could move around it. That's converting electrical energy into movement, which is kinetic energy. Okay, so the question is, which is a motor, which is a generator? All right, so here's a device called a GenCon. Sorry for the sound quality. I had to remove the sound from the actual video footage. But inside we have this cylinder that presumably is the same structure as we looked at earlier. So it has copper wire inside, has a magnetic field, and it has a series of gears. So let's attach an alligator clip to this little device and see what is going on. Alligator clips. All right, so let's plug alligator clip in, and goes directly into that gray cylinder. This is a little device where I can attach a miniature lamp, a little bulb. You guys would go through so many of these bulbs in this lab, maybe 40 of them per class, so we're just going to use one, which is great. So let's attach these alligator clips, and we're going to crank the GenCon to see what happens, which you can imagine, I'm sure, what will happen. Big reveal. Ready? All right, inside I have my little device here with the spinning copper wire and magnetic field and the series of gears, and I can crank the shaft there, and whoa, let there be lights. There is light as I spin the gears of this little device of my GenCon, and there it is. Connect the alligator clips of the GenCon to a battery holder. So I've got my battery holder. It is holding a battery, and it looks like it's walking away in pain, and there it goes. So I have my battery holder and I have my battery. Okay, and I have my copper wire. Nothing's happening. Why? Because there's no magnetic field. So here's my magnets hidden in here somewhere. Now I have magnetic field. And I have a motor. There it is. So cool. I wonder if I can hold it up. Ah. Okay, I love it. I'm gonna leave it there. I'm gonna leave it over. Ah! Here I have a Shake-Lite Forever Flashlight by Excalibur. Okay, so I have a bunch of different kinds of flashlight things here. Here's another one. And if you look closely, you can see that inside there is a magnet that is sliding back and forth. And you can see that because there's the little paper clip to show that it's sliding. And what's inside? Oh my gosh, it's copper wire. Amazing. Okay, so this one I believe works pretty well. The Shake-Lite is amazing and also kind of impractical, but inside there is neodymium magnets, which is such a mess. Okay, they're really strong magnets. Okay, here's a neodymium magnet. It is incredibly strong, and it's made of a special material that generates a stronger magnetic field than traditional iron magnets. So the neodymium magnet carries a stronger magnetic field, which is why I have it hidden away in here, because one time some students tried to attach it to another student's braces. So that was fun. Okay, so here's the Shake-Lite. Okay, let's shake it. There it is, it's lighting up. Shake-Lite! And it lights up, yay! There it is.